Okay, we have section 5.3, question P19, and we're looking at some data from the Titanic, some just basic categories here. Each person, whether they were male or female, and whether they survived the wreck or they did not. There has been a lot of data done also on how wealthy, in other words, what class the person was writing in and if they were more likely to be saved. But this is more of a basic version of the question, just getting into conditional probability. So let's look at these. We have, first of all, the probability of being female. So if we want to know probability of being female, we'll take the total number of females, which is 470, over the total number of people on the ship. And remember, on these contingency tables, the bottom right is where we have our total number of people in the entire sample or population that we're looking at. Okay, this next one is our first conditional probability, the probability of being a female given that you survived, or given that the person survived. So we read this symbol right there as given that. So probability of being a female given that you survived. So in this case, we're not even considering these non-survivors. We're only looking at these survivors. And in that case, the probability would be the number of female survivors, 344, over the total survivors, 711. So everything there is based on being a survivor. That's what that conditional probability is. And it looks strange, it's a little more complicated, but really this is something that you would do all the time in life. You maybe wake up, there's a, say, 10% probability that you would take an umbrella with you, then you look outside, it looks really cloudy. Now you have condition on the fact that it looks cloudy, you're more likely to take an umbrella. Then you check the weather on the internet and find out there's 0% chance of rain, so now maybe your probability goes down. But this condition is basically just giving us more information. The more information we have, the more accurate of a probability we can estimate. The probability of not being a female. So in this case, there's only one other category, which is a male. So these 1,731 would be all the not females. So we put that over the total number of people. Probability of not being a female if you survived. In other words, probability of being a male if you survived. So we're only looking at the survivor column again, and in this case, since there's only one category that's not female, we just take 367 over 711. If there had been another category like gender, third gender, or I don't want to say undetermined because those could have been females also, but we would add those other two columns and then divide by 711 if we had a case where we're looking at not F. And finally, we have probability that you survived given that you're not a female. So here, in this case, we're not looking at the survived row anymore. We're focusing on the given information is that we are not a female. So this is, the person is not a female. So we're in this column now. We're discarding everything else and we're focusing on the not female column. Now what's the probability that we did survive or that a person did survive? Well, that would be 367 over 1731. Notice that the order does matter here. So these are the same things, not F and S and not F. But when we switch them around, it does give us a different answer here because these are two separate things.